Hello everyone. Today we are going to learn 9.1 basics of confidence intervals. Okay, it's chapter 9. Da-da-da. Yeah, we have chapter 9 and chapter 10 almost done. Okay, hanging there. All right. So chapter 9, it's about confidence interval. So we have 4 sections, but we do only 3 sections. We skip the summary. All right. So chapter 8, we had sample data to test the claims, right? Chapter 9, it's about we are using sample data to make an estimate. All right. So 9.1, basics of confidence intervals. Learning objective here. Okay, now we have point estimate, interval estimate. Point estimate, we did that earlier. P-hat, right? So P-hat. So we had name for P-hat is the sample proportion, right? But also this one we can call point estimate because p-hat gives us single number like a 0.2140 or 0.1234 like that, right? So it's a point estimate. But then this section, this chapter, we are going to learn confidence interval, which is interval estimates, right? So we know what is interval means. Interval. So interval looks like that, right? Yeah. So normally in algebra, we learned interval, bracket, or parentheses, bracket, or uh, bracket, parentheses, and parentheses, right? But we are using this section, this chapter, parentheses about interval. And then we do estimate, all right? Okay, so let's take a look at this one. Point estimate, p-hat, it's a sample proportion with a point estimate, we do estimate about the population proportion p. We have a sample mean, x bar. We want to approximate the population mean, right? Okay, then we called p-hat, x bar, unbiased estimators because the means of their sampling distribution are equal to the parameter they are estimating. So what this means? This means when you take many samples, the averages of all those estimates is equal to the true population. Sorry, yeah, it is, right? True population value. So what's the true population value? That means P, which is population proportion, or mu, which is population mean, right? That's the true population value. Yeah. Okay. Now we have uh, S. S is the biased estimator for sigma, which is S is what is called S. It's a sample standard deviation, right? So sample standard deviation, let me write down here. And then sigma for population, right? So let me using pop, yeah, population. Okay, but then we talked unbiased estimators when we talked n-1, right? Why we are using n-1? Because we want to make a best estimate that is unbiased estimator, right? But then in the case, they said the biased estimator. What's going on, right? So look, actually n-1, it's under the square root, right? If we have n-1 by itself, that is unbiased estimator. Means that we can make a best estimate, right? All right, so how do you make it just n-1 by itself without square root? Bingo, s squared, right? So what was the s squared? S squared. Then we get, that is the sample variance, right? So sample variance, let me write down later. So if we make a square them, so there's no square root. So there will be summation x of I minus x bar squared over n-1. Now we say that this is unbiased estimators. So we call this is, they said biased, but we said that approximately unbiased because we have n-1, yeah? But it's inside the square root, yeah? If we were using n, that's a definitely biased estimator. That's why we are using n-1. We talked when we had standard deviation. Remember? Okay, you don't remember? That's fine, okay? So why we did not use n? If we are using n, it's the same formula with population standard deviation, right? And then we are using n-1, not the n-2, not the n plus 1, right? N plus 1, then the denominator is getting bigger. So that is, that is underestimate, right? And if we are using n-2, then there's overestimate, right? So n-1 was the best estimated estimation, right? Yeah. Okay. Now, so we understand that is unbiased. And this is a sample. Oh my gosh, there's noise. Sample variation, right? So this is, we are using n-1, then unbiased estimator, right? So mate means that best estimate. Think. Yeah. All right. Let's move on. So we have a confidence interval. So it's a range of obtained from sample data. It's used to estimate. So we want to estimate the population parameters, right? Okay. What kind of parameter we have? Population parameter. So population parameter we just did earlier, right? P, population proportion. And mu, population mean, right? And we have another parameter, sigma, population standard deviation, right? Yeah. But then we are going to use only two, population proportion and population mean. All right. So they say that confidence interval, so we have interval notation, right? So interval, confidence interval is interval. Yeah, so interval looks like that. Yeah, two numbers right there. So it's a stated level of confidence on interval, which is range, right? So range of values that estimate the parameter, right? So the parameter in the case, we will have P, M, or mu, right? Okay. So confidence interval, we do abbreviated CI. So we are using first letter confidence, C, and second letter interval, yeah, CI. Make sense? All right. So let us do this one. Um, Suppose you read online that 95% confidence interval for, I want to say the confidence level. So we have a confidence level, which is 90%, 95%, 99%. It's a percentage, yeah? So confidence level, 90%, 91%, 99%. It can be 98%, 95% too, but then below 90%, people tend to not to believe that, right? So better than more than 90%. And we don't say that 100% because we are human being. We make a mistake, right? So we're not supposed to say 100%, right? So in multiple choice, always 100% or always those kind of words, then we don't choose that, right? So that's not good word. Anyway, so let us do this. So 95% confidence level for the proportions of students who suffer from some form of food insecurity is, this is a confidence interval. Yeah, so confidence interval. Here, right? So 0.38, between 0.38 and 0.56. What is the statistical interpretation? Okay, so let's write down. So we proportion, right? So we don't know what exact value for the population proportion is, but the confidence level is 95% confident that the proportion of students, the true proportion for student who suffer from some form of food insecurity is, okay, we have a 0.38 and 0.56. We make a percentage, 100%, both of them. Then two to the right twice, so it's 38%. and this is a 56%, right? So suffer from some of food insecurity is between 38% and 56%. All right, that's how we interpret. Okay. How about this? Suppose you read that 90% confidence interval for the average cost of a college textbook is 87 and 125. So average cost, right? So what is the statistical interpretation? Statistical interpretation, right? Okay, so we don't know what exact value for the population means, but we are 90% confident for the true population mean. Population mean cost of a textbook is between, they talk about the average cost, so it's money, so $87 and $125. Make sense? All right. So can you see that? Yeah. Okay. Okay. So there is important tips. So we have 90% confidence level, right? So don't use that. That is the probability. That is not, since that is not probability, we cannot use a chance, right? So that is the important tip here. So we correct interpretation. We have a 90% confidence that the true mean cost of a textbook is between $87 and $125, right? So true mean is population. All right. But they say that we're not supposed to say that probability. Since we don't say the probability, we cannot say the chance, right? So chance, probability, they are same word, right? So don't use that. All right. Okay. So we want to create confidence interval, right? All right. So then we want to find the point estimate first. Then we want to find the margin of error. So we're gonna learn chapter section 9.2, 9.3, yeah? And then we want to compute the interval. All right, so let us do this one. Just understand the basic concept for this section. And then we're gonna get into real stuff 9.2, 9.3, yeah? So we have a point estimate plus minus marginal error, right? All right, so I wrote down what is margin of error. So margin of error is, so we are using the first letter from the error, okay? So E, and what is the margin of error? Margin of error, we using how much the sample result might differ from the real true in the population. So we are using plus minus 3%, plus minus 2% as margin of error. Okay, so here point estimate, which is p hat, and then plus margin, plus minus plus minus margin of error, or later on we are going to use x bar and plus minus margin of error, right? Okay, then if we have an interval notation, so we have a confidence interval, right? So if we are using interval notation, we have a lower limit for the left parentheses, and then upper limit for the right side parentheses, yeah? So then since interval notation, we have in order, right? So first number is smaller than second one, right? So small number and bigger number, right? So we have that. So small number and bigger number, right? That's what we have. Point estimate minus margin of error, smaller number, right? And then point estimate, add margin of number, margin of error, then bigger number, right? So x bar minus margin of error, x bar, not the x hat. Sorry. X bar, margin of error, x bar plus margin of error, right? Interval notation, both of them. Okay. Yeah, here's nice pictures. So this is a p hat or margin of error in the middle, but we're not using that. Just to show that, right? In the middle. Then, if we are using interval notation, this number will be p hat minus e or x bar minus e, right? And we are using interval notation, this number will be p hat plus margin of error or x bar plus margin of error, right? Okay, now let us do this one. Example 3, in a study of 1,000 shark attacks, a researcher found that proportion of non-fatal attacks is 72.6% with margin of error 2.76%. Ooh. Sorry. She was 95% confident in this interval. Identify point estimate. Okay. So first one. 72.6%, right? So it's a percent. So we want to make a decimal point estimate, single number, right? So that will be point times 0.01 or divide by 100, right? So that will be move to the decimal point to the left twice, to the left, Beyonce method, right? So we talked before, right? So that will be 0.762. So that will be p hat. That's point estimate. So 0.726. Yeah. Okay. Now, second one, compute lower and upper limit. Okay. Once again, we have a percent, so that will be 1, 2. So second one, the margin of error, we get 0.0276. All right, so lower limit, we have lower limit. Let me write down limit and upper limit. Yeah. So lower limit will be p hat minus margin of error. Upper limit will be p hat plus margin of error, right? Okay, that will be p hat 0.726 minus 0.0276. Can you please calculate? Plus 0.0276. Okay, so thank you. 0.6984 and 0.7538, right? Okay. Now state and interpret confidence interval in context, right? So we don't know. Let's take it out. We already know how to say it, right? So let's just using that we are 95% confident, right? So let's do that. We are no, the researcher, yeah, we can say that. Not we are, because she, yeah. So the researcher is no way. This is the researcher is 95% confident that the true proportion of shark attacks. Let me just write down everything here. The proportion of non-fatal attacks is between is between change it to the percentage. So we have 1, 2, 1, 2. So it's a 69.84% and 79.36%. Yeah. Okay. Let's check. Here's a nice picture. So I want to bring nice picture, and then this one as well. So in the middle, we have a p hat, which is point estimate. And left hand, we have a lower limit, right hand, upper limit, right? I brought this one here. If we are using inequality symbol, then we say that the true proportion is between here, right? So we are using this form using inequality. So like that, okay? If we are using interval notation, Yeah, we did earlier, right? So interval notation is like that. Make sense? All right. Okay, so let us do this example. In a study of the number of miles that bicycle tire will last, a researcher is 95% confident that the mean life expen- expectancy expectancy for bicycle tire is between 452 and 576 road miles. Okay, so identify point estimate. Okay, so it's a mean life, right? How do you do? This one does not give us directly, but we have to find out by using those information. Yeah, so we have a 452 and 706, 576, right? Okay, so that means, look, we have 452 and 576. There's a confidence interval, right? So let's denote confidence interval. All right, then look, we had point estimate is in the middle, is in the middle, right? So we talked. So in that case, export, right? Then this will be export plus margin of error. Uh, yeah, let's make it just equal. Yeah, this is export. Here is export minus the margin of error, right? Okay, now we have two numbers, which is x bar minus margin of error and x bar plus margin of error, right? So how do we find? Okay, let's take a look this one. This is what we did, right? So if we have given two numbers, how do you find the p hat, which is point estimate, right? So we do backwards, yeah? So we are given two numbers. How do you find the p hat in that case, right? So p hat is in the middle. How do you find the middle number, right? Very good. So how do you find the middle number? We add two numbers, divided by 2, right? Okay, let us do that. So export. So in that case, point estimate is X bar. So we do estimate the population mean, which is mu, right? So X bar estimate mu. So X bar equal to 452 plus 576 over 2. Can you please calculate? Yeah, 514. Okay, so X bar will be 514 there in the middle, right? And this is a 452, and this is 576. All right, good job. Now we want to find margin of error. Okay, let's take a look here. So we have two numbers is given. So pretend we don't know about the margin of error. So I'm hiding, right? So just the two numbers is given, right? Okay, how they find the margin of error from here? Because margin of error is inside there, right? Can you can you think? Okay, so we subtract. So we subtract this number to this number, right? And we divide by 2, then we find the margin of error. Or we can think about, if we know the p-hat in that case, then 0.7536 minus p-hat, then that's margin of error too, right? Can you think about that? Yeah. So let us do the 2 ways, all right? So one way to find the margin of error, let me write down margin of error. E, right? Okay, so we are using the number 576 minus 452 over 2. Then what do you get? 62? Okay, now number 1 or number 2, we can find what is called the bigger number minus x bar, right? 514. Can you calculate? Is it 62 as well? That's also margin of error. So either way, we can find the margin of error by given information, right? Okay. Or you can check it out. You can check. How check? Other side, right? So other side. 514 minus 452 equal to 62. Yeah. All right. Let's check that. Okay, so I want to talk about sample size with marginal error and interval, confidence interval. Yeah, so we have a confidence interval, small sample size leads to large marginal error. This is larger than this one, right? And small sample size leads to the largest marginal error. If we have large marginal error, think about that. So plus minus marginal error, right? So this marginal error is larger than the confidence interval is more wider because number is getting bigger. If we have a plus, we have a minus, the number is getting smaller, right? So the confidence interval is larger. Make sense? Okay, then larger sample size leads to smaller margin of error. Yeah, then smaller margin of error, that means plus minus margin of error, right? If then margin of error is small, then number is smaller for the positive, right? And then negative, we have also smaller than the above, right? Yeah, because margin of error is small, right? Make sense? Number is both small, right? Okay, so why small sample size leads the largest marginal error? Why large sample size leads smaller marginal error? Because the marginal error means how much sample. Let me read. Okay, so I wrote down this one. All right, marginal error, how much sample estimate p hat or x bar might differ from the true population value, which is, we talk about the population, true population value, which is p population proportion, right? And mu, which is population mean, right? Okay, so that's why we want to make a more estimate, better estimate. So we are using plus minus marginal error. So we call the interval estimate, right? Okay, so that means if we have a small sample size, then it's better we have to make a bigger marginal error to better estimate, right? If we have a large sample size, then that is really good, right? So that is more accurate to estimate true population value, right? So we don't need that much marginal error. Make sense to you? Okay, so let me talk about why narrow confidence interval, right? So we talked why, right? But then this means I highlighted larger sample size leads to smaller marginal error. So what this won't happen? What did it mean? What this mean? If we have larger sample size lead smaller marginal error, and then if we have a smaller marginal error, then the confidence interval is get smaller too, right? So that means narrower confidence interval, right? So that means more precise. Make sense? So if we say that this is 95% confidence level, and this is 90% confidence level, right? So 90% confidence level narrower than 95% confidence level. So narrower confidence level, they have larger sample size. If we have a larger sample size, that means the largest sample size leads smaller marginal error. If we have a smaller marginal error, then we have a less confidence interval. Interval, yeah, makes sense? Interval is different with confidence level. Make sense? Okay, so summarize here. Larger sample size, smaller marginal error, because we don't need that much marginal error to estimate the population value, right? True population value. So smaller marginal error makes a narrower interval. Clear? Okay. Yeah, higher confidence, lower confidence, same, higher, say 95%. Then we had earlier larger marginal error. If we have a larger marginal error, then they have smaller sample size, right? Yeah. Then we say the wider confidence interval. and lower confidence. So that is the level. They talk about the level. Yeah, level. We talked earlier, right? So say 95% here, say 90%. Yeah, we talked earlier, right? Okay, let's just talk about this one. Higher confidence level, larger margin of error, and wider interval, right? Lower confidence level, smaller margin of error, and narrower interval. Make sense? Yeah, you don't have to memorize, just think about the concept. Yeah? Okay. All right, so let me copy this one and then let us do this question. Then we are done. All right, so let's do this example. So which interval has the smallest margin of error? Okay, so which interval will have smallest one, right? Smallest one. Smallest one. And largest margin of error, right? Okay, so let's take a look. We have a smaller margin of error, larger sample size, lower confidence, right? So let's take a look. Larger one, the smallest one first. Sorry about that. Smallest margin of error. So let's take a look. Larger sample size. So this is a larger sample size, but then lower confidence. So this will be smallest one, right? So C is the smallest margin of error. Okay, let's talk about the largest margin of error then. So largest. Okay, then we think about the opposite, right? So smaller, note, larger margin of error. Small sample size and higher confidence level, right? Okay, let's take a look. Small sample size, yeah, and then higher. Okay, B is largest margin of error, right? So B is the largest margin of error. Yeah, makes sense? Okay, we are done for this section. So we are going to more deeper about confidence interval, which is interval estimate, right? Okay, so I hope you understand. I will see you in the next section. Thank you for watching. Bye.